What program?
A function does not have to be a graph. It doesn't even have to be an equation. Okay. The general idea of function is this. You have something that does something. And this thing that does something, so when you say does something, it does something to what? Okay. So we call this is, so it's I think the machine, being a machine is a very popular way of talking about a function. So input, you put something into the machine. The function does something. It comes out. Now, as long as it only gives you, for every input, it only gives you one output, this machine is a function. So for every input, there is only one output. Okay. This is the more general definition of what a function is. So someone think of a machine, any machine.
Optimus Prime.
Not Optimus, something, a tool you use. Clock? Okay. Okay, let me break, okay, so pick a machine that you need to put something into it.
Oh, the magic bullet.
No,
The magic bullet?
player?
You put food into it, it does something.
Okay, the magic bullet. Alright. The magic bullet, you put a bunch of fruits into it and you grind it, right? So the input is a bunch of fruits, but every time you put something in there, you grind it. You get a grinded result. You don't get something other than the grinded result, right? So that's, you can think of it as a function. I think you can also at the same time argue, but you get different kind of grind depending on when you stop. Right? And depending on how much you put in. But I can still argue it's a function. Because if you could precisely measure exactly what you put in, which is a particular input, like different fruits, exactly same size, 3 oranges, right? Or like 3 tomatoes. You want to make tomato sauce. And then you perfectly put it in here and spin it for only 5 seconds. You're going to get the same thing every single time. Right? So the output is still 1 for whatever you put in. Now actually all machines behave this way. All machines that you will buy. If you get a machine, sometimes you do this. You bought this machine for a particular purpose. But then sometimes it does this, sometimes it does that. You can't tell. Like, you're just out of luck. Would you buy this machine?
Surprise me.
Yeah, like, just surprise me. Maybe it's a game. Like, they randomly give you output. Those are actually they're not functions. Like, those are maybe horoscope things. You shake it, and it's something, every time you shake, something different comes out. That's not a function. Right? But anything that's useful is a function. Okay, here's the first machine which puts on your socks. Let's have a second machine which washes your feet. Okay. And let's have a third machine puts on your shoes.
That's silly. Why would you put on your socks and then wash your feet?
So actually keep those machines in mind, okay? Just in mind. I'm gonna do a normal looking math question first. I'm gonna explain to you why it's the same thing as washing your feet and putting on your sock and things like that. So suppose f at x is 2x, and suppose g at x is equal to x squared minus 1. So what is f at x squared minus 1 then? So this, by the way, I hope everybody's familiar with this symbol. This function means I'm going to do something to x. On the right side, it tells you what you're doing. I'm going to do something to x. I'm going to double the x. That's what this is. Okay. So a lot of people think this is a multiplication of f and x. That's not what it means. I'm going to do something to the x. What is it doing?
Squaring.
And squaring it, subtracting 1 to it, right? That's what these symbols mean. Okay, so here, I put x squared minus 1 into the f. What is it going to do to x squared minus 1? It's going to double it, right? It's going to double it. Okay, what about the other way? Let's put 2x into g. What is g going to do to 2x? It's going to take 2s. So g, no matter what you put into it, it's going to square it and subtract 1 in. So what did you put in? 2x, right? I'm going to square it and subtract 1. So this we're going to talk about more in detail in a few classes. But what if you put x into g and you take that result and put it back again into g? What is it going to do? What is the equation going to look like? Yeah.
You get like an infinite loop.
No, we're looping it once actually. If you've done computer science, we're just looping it once. So this can be replaced with x squared minus 1, right? So what is g going to do to x squared minus 1? Square minus 1. That's what's going to happen. So what the f and g does, it doesn't care what you put in, it does the exact same thing to it. It's like these machines, right? Puts on your sock, washes your feet, and puts on your shoes, right? So if you put your feet in here first, right? So let's say your feet is x. This is the notation for I'm putting my feet into the machine g first. Oh, it washes my feet. Okay? And then it's like, oh, okay, where should I put my feet now? It's washed, it's clean. I'm going to put it into H. That's a symbol for this. What is it going to do to it? What is it going to do to your clean feet? It's going to put some shoes on, right? And then like, I forgot one of the machines. So I'm going to put it into F. What is it going to do to it? Sorry, this is G. It's going to put socks on your feet, right? With the shoes already on it, right? So obviously you got to put your, but do you see what I mean? The machine doesn't care what you're putting into it. It's going to do the same thing to it. These functions, but you have to read them like what they do, what their action is. This is doubling. This is squaring minus 1, right? So that's what they do.